So hello everyone, my name is Hencz Akos and I am a backend developer from the Collaboratory team of the HBP's Project Coordination Office. And this presentation is going to be about using the Collaboratory, which Luca already covered partially, but we will go over it again nevertheless. And the second part is more focusing on notebooks, how to use them, and some of the specifics about notebooks in the Collaboratory. So to begin with, what is the Collaboratory? It is a virtual lab bench. It is the Human Brain Project's humble effort to create an ecosystem for the neuroscientists. And what follows is a short demonstration on how to use it. So first, once you have your account and you log in, you maybe want to create your own workspace. So this is the main page of the Collaboratory where you land after login. You've already seen this, and Luca explained it a little bit on the top. You get the main navigation items, your profile, your list of collabs that you're a member of, notifications, and a button to log out. And already the main page is kind of a collab. The left navigation is contextual. It always belongs to the collab that you are on. So this one is the Collaboratory Home collab. It is public and I'm a member. And on the left side of the navigation there is a link to create your own workspace, which we call collab again. I can give it a name. I can give it a description, my super project. I can decide about access rules, which is either public or private. Public in this context means that anybody who has an account to the Collaboratory can access the information there, but cannot change. And private means that only people who are added to the collab itself can view the content. So I'm going to create this collab now. And my workspace is created and it's initialized with a couple of applications right from the start. So in the navigation item you see 4 entries, and the overview is a kind of a dashboard of recent activities, who did what, who are the team members, and so on and so on. So this is how you create your own workspace. And now maybe you realize that you're too alone and you want to invite your teammates. And anybody can do that if you go on your profile in the upper right corner. You are redirected to a special collab that shows your profile, your activity, like what did you do before. And it also contains the link to invite a user. You can give your friends or colleagues email address. You can customize the message and send an invitation, which will send an email with a link that will allow your colleague or friend to create his or her account on the Collaboratory. And that is how you invite teammates. And now that you have a teammate, you want to invite him or her to your team, because that's a team is better than the sum of its members. So I go back to my collab. Oops. That I just created. And there is a navigation item called Team. And by default, it shows me who are the members, which is at the moment is just me. And most of the apps in the Collaboratory have a view and an edit mode. So this is the view mode. And if you want to edit it, then there is a little cog icon in the top right corner of the central pane. If I click it, I can actually edit the team composition for this collab. And I have a test account, so I'm going to invite my test account to join this collab. And it is now there, so I can exit the edit mode. And you can see that now we are 2 in this team, and the team member has access to everything that I have access to. And that is how you create oops, I'm sorry. That is how you create a team. And maybe now you want to write some content that you would like to share with your team. There are multiple choices for that, but they all start the same way. So in your navigation, you want to click Add to add a new page or a new application to your collab, and then you're presented with a list of applications that are available to be added to the collab. And for static content, the two most common ones are a rich text editor, or there is a Markdown document. I'm just going to go ahead and add a rich text editor for now. I click Add to Navigation, and there is now a new navigation item in the collab. I can change its title, like Welcome Guide, and I can write the content, Hello Visitor. And this is a rich text editor, so I can make this fairly big. I save the contents. Then I exit the edit mode. Oops, that's not what I wanted. And then only the content is visible. So whenever somebody is coming to this navigation entry in my collab, they will see the content I have written. And so that is how you write content in the Collaboratory. Maybe you also want to share existing documents with your team. And the way to do that is by using the Collaboratory's own storage service. By default, in every collab, we create a storage space in a specific service. And we provide a link to it in every collab created. So if I click this navigation item, I am presented with an interface where I would see files and folders, and this one is currently empty. So I can click this little wrench icon here, and I can say I want to create a folder. I'm going to name it Documents. So now you see I have a folder here on the left side navigation. I click on the folder, then the breadcrumbs are updated to show that I'm in my collab and in my documents folder. I click this icon again to upload a file. I'm going to select a file. Whew. I don't know what's something small here, this one. So I uploaded this one file, and now it is in the storage. So if anyone in the team, or if this is a public collab, comes to the storage, they can browse the contents, click on the file, click download to get the contents. Or if you think this is very important and you want to have quick access to this document, then you can click this button to add to Navigator, which will create a direct link to the storage item in the left navigation pane for quicker access. And that is the way to share documents in the Collaboratory. And next up is how to analyze data. And the recommended way is to use Jupyter notebooks that you will hear a lot about later on. And Jupyter Notebooks makes it easy to share workflows, create tutorials, and it is by far the most popular application in the Collaboratory. And the way you can create new notebooks to share with your colleagues is, again, to go to the navigation, you click Add, you start typing Jupyter, because they're Jupyter notebooks. So here are the notebooks. I can add it to the navigation. And there's now a new navigation entry that's called Jupyter Notebook. It asks me if I want to create a new notebook, or I want to load one from the provided storage, or if I want to upload an existing notebook, I'm going to create a new one.
Jupyter 3?
Sorry?
Is there Python 3?
Yes, there is Python 2 and 3.
Because it only said, okay, sorry.
Yeah, we will talk about it later, but yes, there is both Python 2 and Python 3 available for notebooks. Now, this does not look very fancy in the navigation list to just call it notebook. So if I click the cog item in the navigation pane, I can actually rename this to, I don't know, like simulation notebook or whatever that describes the content best. And I cannot type. Yeah, that's a lot of typos, but okay. And so now it's a more descriptive title in the navigation item. I could show you one of the notebooks that I have, and because this is just how to add the notebook, but it does not really show you why you should use this to analyze data. So one personal example would be in my own collab. No. There is a notebook that I used for Google Analytics because we use Google Analytics to measure the visitor data, and I can actually fetch data from the API of Google Analytics, do some transformations, create pandas data frame, and then create all kinds of plots and diagrams to see which ones are popular collabs or which ones are popular applications inside the collaboratory. And I can easily share this with my colleagues. If they want up-to-date data, they can just rerun the notebook and they get data from the past couple of months. So it's a useful tool. And that would be the way to analyze data in the collaboratory. And now a little bit about exploring the ecosystem itself. Until now it was only about managing your own collab. And you can do that mostly from the main navigation. So as Luca already said, there are the links to the platforms, the main platforms in the collaboratory, up from the main menu. So you can visit the brain simulation platform that Luca was already demoing. You can look around in their collab, see what they had to share. You can also go to the collabs menu in the main menu, and you can just search for the existing collabs by keyword, and you will only see collabs that are either public or they are private, but you're a member, so you're allowed to see it. And also, if you just want to see your own collabs, you can go to this this quick list here in the top menu, and again filter by keyword to your own collabs to shorten the list. And other helpful information can be found in the help menu, in the main menu, where we describe something about the collaboratory, the identity service, the frequently asked questions. One that you might find interesting is the Jupyter notebook how-to that is a link to another collab that is focusing on explaining the Jupyter notebooks in the collaboratory, how to use them. There are some sample notebooks as well. So it could be useful for your work.
It is kind of difficult to hear what you're saying. From here.
I'm sorry.
So you can just speak from me. Either louder or I don't know. Maybe we can use an amplifier.
I can try to speak louder.
Okay, thank you.
Okay, so this concludes what I thought would be the way to explore the collaboratory. And this part, the extending collaboratory with your own applications, I'm not going to demo because it's a fairly complex topic and it's not really part of this presentation. But when you saw me adding items to the navigation menu, there were a bunch of applications, and you can create your own. It's not so simple, and you have to be an HBP member, but just so you know, it is possible to add your own applications to extend the collaboratory's functionality. Okay, to recap what you have seen so far, you can now invite other users, other team members. You can create your own workspace, or collab as we call it. You can build your own team to add them to your collab. You can write your own content, static content. You can share existing documents and data through the storage service provided by the Collaboratory. You can analyze data using the Jupyter notebooks, and you can explore the HBP ecosystem as presented through the Collaboratory. So the key ideas or governing principles behind the Collaboratory itself is to bring the community to the main platforms and serve as a sort of entry point for researchers to find the platforms. And then in turn, the platforms would provide their own tools in their own specific domains, and they leverage the Collaboratory infrastructure. Another goal is to provide integration to glue the platforms together with shared services and a common user interface. And also to enable reproducible science by focusing on making notebooks an efficient and productive tool for large-scale collaboration. Now a couple of words about the future of the Collaboratory. We look forward to integrate Jupyter Lab. So you have seen notebooks so far, and Jupyter Lab is the next generation interface to work with notebooks, and it contains a lot of improvements. So we're looking forward to this. We also would like to add better search functionality to the Collaboratory, because right now the discoverability is a little bit lacking. And we would also include or integrate a fully functional chat service that can be useful on events like this, people coming together from different organizations, everybody is using a different chat service. It could be difficult to quickly discuss something, share links, these kind of things, because some person might use Slack, another person might use Skype, and maybe some institutions also have limitations on what services can be used on their networks and not. So this would be a nice addition to provide for our users. And some other topics of improvements: we would like to improve the data flow, meaning the data that you can access in the Jupyter notebooks. It's now can be a bit tricky to get your data into the notebook where you actually want to analyze it. We would also like to implement some sort of notebook versioning, because at the moment, if you make changes to your notebook and you save them, there is no way to revert to previous versions of that notebook. And we would also like to create a better permission service, because at the moment, as you saw, you can create public or private collabs, but there is no fine-grained access control, which means that in a private Collaboratory, a member can basically edit any content. You can't limit what they can and cannot do. And so the next part of the presentations would be focusing on Jupyter notebooks that you have heard so much about already. Who here is familiar with Jupyter notebooks to some extent? Yeah, quite many?
It's very small.
Okay. So Jupyter notebooks are an open source web application, and they are created by Project Jupyter, a non-profit organization. It is meant to create and share documents containing various types of contents, like executable live code, equations and visualizations, and also narrative text. And the combination of these various types of contents make it an ideal choice for demonstrations and tutorials, online courses. They are good to reproduce different tasks, given they have the same environment. And I also use it myself for prototyping and experimenting with other software APIs, because it's just comfortable and handy to use it for that purpose as well. Oops, I'm sorry. So it has three core parts, Jupyter notebooks. There is the notebook document itself. It's basically a text file with a humongous JSON object in itself. The interesting thing about it is that you can also save the output of your notebook. If it's not some fancy plot, maybe even that, but some textual data, then those are also written into the JSON object, and your document is fully portable, including input and output. The other part is the notebook app itself. It is a server client application which is responsible for displaying, editing, and running the live code via the browser. And there is the third part, which is the kernel, which is responsible for executing the live code behind the scenes. We will be mostly using Python kernels, but there are some kernels existing for other languages as well. And now, instead of talking more about them, I prepared a small notebook to demo its features. So in the Collaboratory, if you want to get rid of the clutter on the left and top side, then on the central pane again, next to the little cog, there is in fact a maximize button, so that the content takes over the screen and hides the navigation items. So this is a notebook. As Luca was already saying, it consists of cells. Like one now is highlighted with this blue frame. And I was saying a notebook is a mix of different type of content, narrative, live code, and visualization. And this here would be the narrative text. This is static text. It's called, it supports Markdown Rendering. Markdown is a markup language similar to HTML. So you can create headers, you can link images, or create some formatted text. It's simpler than HTML. And basically renders a very similar output that you can do by running these cells. And to run a cell, you can either use a key combination, Shift-Enter, Control-Enter, or you can go to the menu and run a specific cell, or run all cells below a certain point in the notebook, or all cells above a certain point in the notebook, or just run all cells. But I find the hotkeys the most efficient if I just want to execute individual cells. So then there is live code. Here I define a simple string variable. Then I print this simple string variable. And so far I've been executing cells in order. But in fact, one of the great things about Jupyter notebooks is that you're not forced to execute them in the order they are written in the notebook. So for example, I could decide that I want to execute this cell first, and this will fail because I'm trying to reference a variable that has not been defined yet. So I actually have to go back to the previous cell, execute that one, and then this next one will execute just fine. You can also see the execution order of the cells in the brackets next to them. So this cell was executed first, this was the second. The third one is missing because it was originally this cell that I now executed again as the fifth execution, and the previous one was the fourth execution. So far, every cell that I have executed contained only one single instruction, but it's possible to write multiple instructions in one single cell and execute it just in a bunch. So this one does nothing really, just some arithmetic operations and some prints. And just to show you a little bit of visualization, this is a very basic, this is a very basic plotting. You can do that too. And one thing that needs to be talked about a bit more is the kernel, which is responsible for executing the code cells. And in the next cell, I have written some instructions that are waiting for 10 minutes. So I'm going to execute that. And then I see that this cell is still in execution. You can see that in the brackets next to it, there's a star. This means that it's currently being evaluated, interpreted, it's running. And you can also see this on the top right corner. This is the kernel indicator. It says that I'm using a Python 2 kernel, and the full circle means that the kernel is currently busy, that it's working. And the thing is, if I now want to execute the next cell, it's also going to wait because the kernel executes the cells as they are coming in, and it's still working on the previous cell. So even this is a very simple instruction. It's not going to be executed until the previous one finishes. And maybe I realize that I have written an infinite loop or something. So what can I do in this case is that I can interrupt the kernel. You can do that either by clicking the stop button here in the menu, or going into the kernel menu and just say interrupt. And that it kind of works like hitting Control-C during execution, so it's a keyboard interrupt. You can also restart the kernel, and the big difference is that when you interrupt the kernel, then the variables are not lost. Whatever variables were defined and initialized before, they are still here in the memory after interrupting the kernel. But if I restart the kernel, that's like starting a fresh sheet. The memory is wiped. Anything I have declared before is lost. So if I now restart my kernel with this little circular arrow item, kernel is ready. Okay, I try to execute again this cell, and it tells me that this variable is not defined. So that raises a question like, why would you want to restart your kernel? And the most common use case is you have used some libraries that are already loaded into the kernel's memory. You upgrade these libraries, but the kernel is not going to pick up the upgrades until you restart the kernel. I have an example for this here because we import one of the libraries for every notebook that is started. And I can print its version. So now it's 0.0.3. That is the version number. I can execute a command to change the version of this library. So it's updating the library. And maybe some of you would say that you could just use the reload function in Python that is meant to reload already loaded modules. So I can try to reload this module, and just I will import it again. I will print the version, and it's still 0.0.3, even though on disk I changed the library, and it should be 1.0.0. And that is the point, when I have to restart the kernel, so that the import is actually happening from scratch. So now I import this module again, I print the version, and yay. And it's 1.0.0. So that is the most common reason why you would want to restart your kernel. Some other nice features of Jupyter notebooks are magic functions. They are here to make your life easier. So one of the first one is to list other magic functions. And magic functions normally start with the percentage sign. So I can execute this cell, and this is not Python code. This is some special keyword that the kernel will recognize and list the other magic functions. There is another magic function called quick reference that gives you a little cheat sheet here in a button pane as to what you can do with the kernel, and gives you a short description of other magic functions. So some examples of what you can do with magic functions, like print the current working directory for the kernel. And here in the ls magic, you can actually see a message that auto magic is on, so the percentage sign is not necessary. So I can actually run the same magic function without the percentage sign in front of it, and it's still evaluated. Even though I like to keep the percentage sign to make it clear what that cell is actually doing, it makes it clearer to read. And some examples, like what you can do with the magic functions, is to list directory content. You can list the environmental variables available for the kernel. You can also manipulate the environmental variables. You can set one. You can query one. And that's a quick intro to magic functions. Another useful feature of Jupyter notebooks is that you can also execute shell commands by putting an exclamation mark in front. So any valid bash command can be executed just by putting an exclamation mark in front. So here I'm executing commands to give me what is the user locally that is running the kernel. It's called Jovian, and what is the home directory for this user? It's home Jovian. I can check which Python interpreter is used by the kernel. I can run pip commands to get information or manipulate Python libraries. And that's all you have to know about the running shell commands in the notebook. Some other tips that I find very useful and handy.
Limits on the shell?
Sorry?
Limits. What are the limits on having a shell? Using a shell?
Sorry?
What are the limits about using a shell? Move the shell and think of it as
Yes.
upload files, do SSH, do...
That might be difficult because, as later on I will show you, this is running in a Docker container, so the network settings might prevent you from launching an SSH connection from inside the container. I would say it's not going to work. It's a good question. What are the exact limitations? You have to fiddle a bit to figure out because it's a special environment. Some things might work. I know that you can download files with wget or use curl. But SSH tunneling, I'm not so sure that the network settings will allow that.
So, well, I mean, there's a billion questions in here, actually.
Yeah. Maybe we can discuss that later. So other useful features of Jupyter notebooks, you can put a question mark after any object in the notebook. Like this is a question mark after a magic function. If I execute the cell, I get the doc string in a pane just below my notebook, which is really convenient if I don't want to open a documentation in another browser window or another tab. It's right here. I can read it. I can use it. The same is true for certain variables. Here I create a simple dictionary and then put a question mark after the dictionary's name. So I immediately get some information about this object in memory. But also you can use the question mark on regular Python functions. So this is the pop method on a dictionary. I just put a question mark after it instead of the opening parenthesis for the method. So now in the button pane, I get the document string for the dictionary's pop method. Again, I don't have to open the documentation in another browser window. It's right here in front of me to use. Then another useful feature of Jupyter notebooks is that they provide autocomplete. So to show that, I'm going to create this object from a built-in method. And now I'm writing my code, and I created this object, which is returned by a method, and I have no idea what can I do with this object. But I can just try maybe use the question mark. I get some sort of doc string, but I can also try to start typing dot and hit the tab, and then autocomplete window opens where I can just choose one of the members of this object. I choose this one. I say tab again. I get a list of methods that are available at this point on the object. I choose one of them. Now I don't know what to do with this method. I don't know what parameters it has. So I can hit Shift tab, and then I get the contextual information right below the cell. Oops. I can make this a little bit bigger with the plus sign, so I actually get the full doc string of the method, so I know how to use it exactly. And again, the advantage is I don't have to open the documentation somewhere else and switch between tabs. It's right here. I can type. I can already use autocomplete. So again, very convenient. And my last tip would be to use the debug magic function. It is extremely useful. So I have a cell here that is going to cause an exception. And yeah, it's not pretty. But then in another cell, I can execute the debug magic function, and I get an interactive debugger right at the line where the exception was raised, and then this works like the regular Python debugger, so it receives the same commands. I can type help to see the available commands in the debugger. I can move up the stack. Oh, sorry, that's another cell. Huh? I can move up the call stack. Still, I can print the local variables available at this frame. So it's very useful to dig in a bit in an exception of what just happened to quickly fix the problem, because people sometimes find it weird in the notebook environment to get to the bottom of this, but in fact the notebooks provide the tools to do that. So these would be my most important tips on Jupyter notebooks. Yes?
What else did they add to Jupyter? What was the next version of the Jupyter? You said
Jupyter Lab.
Jupyter Lab. So what else can be in Jupyter Lab, but not Jupyter Notebook?
I'm not sure about the technological background. I did not play too much with it, but the interface is very different. It's closer to an IDE, an integrated development environment. So you can open multiple notebooks, and they are placed in tabs, like in a browser. It makes it easier to use, but I can't answer specific technological differences. I think the idea is still the same, that there is a kernel behind every notebook executing the cells. I'm not sure of the exact differences, but I can show you a way to try it yourself. So now we saw how to use notebooks, and now I will show you about the software environment that the code is executed in. And this environment is your personal environment, which means is that the environment is per user and not per collab. So what this means is that it's possible to modify the environment, including installing or removing or upgrading Python libraries, and not system libraries though, because those require root privileges, which you simply won't have. But when you modify these libraries, it will only be available to you. So let's say that you have written a notebook that relies on a library that is not available out of the box, so you installed it. Your colleague comes, executes the same notebook, and the library is not going to be available to him unless he installs it too. So there is a way so that you can write it into your notebook that the dependencies on which the code relies are actually satisfied by executing or installing the specific libraries and versions that you need. So whenever somebody executes the full notebook from top to bottom, it will start by making sure that the environment will match what the notebook expects. And another important aspect of the environment that we provide is that the storage is not persistent. So if you're writing files to disk, they may not be there if there's a service interruption or something crashes. There will be no way to recover that. So the best way to work around that is to use a storage service that the Collaboratory provides, because that's persistent storage. So whenever you want to save or load something, it is possible to load or save it into the storage service. We also inject the user credentials to the container specifically for the reason that the integration is better with the Collaboratory services, and then you can then use the storage service without having to authenticate first and do all this by yourself. So the environment has these characteristics because of the underlying technologies, which is Docker and Docker containers. Probably many of you are familiar with these terms or the exact technology. But just to recap, it's a lightweight virtualization. It is based on Linux kernel features, C groups and namespaces, where namespaces isolate and virtualize system resources for a collection of processes, and C groups or control groups limits, accounts for, and isolates the resources for the collection of resources. We provide one Docker container per user. There is then one notebook server running inside the container. But then you will have many kernel processes per server because there is a one-to-one mapping between open notebooks and the kernels executing the live code for the notebooks behind the scenes. So how does this look like as a process tree inside the container? So this is the process list inside the container. And I can scroll this window, which I normally should. But the entry point of the container is PID1. It's basically a shell script that is a wrapper around starting the notebook server. It injects your credentials. It installs some extensions by default. And then the next process on the list is the actual notebook server. And what you see on this screenshot is two other Python processes. Those are basically the kernels running the live code cells for two different notebooks. And they are the parent processes of the notebook server. Also, I can show you this. How does this look like? By opening a live terminal into my container. So I have a terminal inside my container. I can check the running process list. And the first process is the wrapper. Then there is the notebook server. This one here is the actual terminal that I'm inside. And then there are a bunch of kernels for notebooks that I have opened so far. So there is currently 4 of them. But if I go to the collab and open another notebook, when it opens, okay, so now I should have one more kernel than I had previously. Yes, so previously there was 4 and now there is 5. And you can see that these kernels are actually using a Python 2 interpreter because this is a Python 2 kernel. But if I go back to this one and switch the kernel from Python 2 to Python 3 and go back to the process list, you can see that the last line doesn't say Python 2 anymore because it's a different Python interpreter, and that is version 3. And it's good to notice that, or keep in mind that these are isolated processes, so the memory is not shared between the notebooks. That means if I have notebook A open in a tab of my browser, I have another notebook open in another tab of my browser. If I declare a variable or define a function in one of the notebooks, it will not be available in my other notebook because they are completely isolated, separate processes. Okay. Oops. So the initial state of this environment that you're working in is defined by a Docker image. And we use the same image for all users. It's a one-size-fits kind of thing. And it's currently roughly 4 gigabytes in size. It has 146 libraries for Python 2, 140 for Python 3. This includes all the basic libraries that is actually required for the notebooks to function, and also some of the additional ones that are most commonly used by researchers. And we sometimes receive requests to make changes to the default environment, which we always try to oblige and make it happen. It's not always so easy. Sometimes changing libraries lead to conflicts. People's notebook might break because they expect a certain version of a library being present, and then we suddenly change it. It's not going to work. So it's not as easy as installing a library and pushing it out to production. So about these libraries, as I mentioned, you can change it yourself. You can install other versions, get rid of them, whatever you like. But this change is only valid for yourself, nobody else. So keep that in mind. And also the changes are not persistent, which means if the service crashes or we restart the service because we do a service intervention, upgrade the components, the servers, whatever, then your environment and all the changes you have done will be gone, and the next time you open a notebook, it will be back to the original state. We also provide pip2 and pip3 aliases, so you can conveniently manipulate the libraries for both Python 2 and Python 3. And what to do when something breaks, because that sometimes happens. You have to ask us to delete your container, so the next time when you open a notebook, behind the scenes the service will instantiate you a new one, so your troubles will be resolved, hopefully. So about the service architecture behind all this, the software stack, we use Jupyter Hub. You have heard about Jupyter Notebooks, but you have not heard about Jupyter Hub. It's basically another software product from the same organization that was meant exactly for this kind of use case, where you want to cater to a large group of people and provide the notebook service for a broader audience. And what it does is that it spawns and manages individual notebook servers for a lot of people. And as a component, it uses the Docker spawner, which is a pluggable spawner class within the product. And this one is called Docker spawner because it relies on this specific technology. We picked this ourselves, but there are other spawner classes to instantiate the notebook servers for the individual users. You can use systemd, Kubernetes, Slurm, and a bunch of other ones. And we are considering perhaps moving to Kubernetes in the future. We obviously use Docker for the virtualization, and because the whole software stack depends on it. We also use Docker Swarm, which is the native clustering for Docker. And what it does is basically you can run Docker on several servers, and it will provide an overlay, and the whole cluster of servers will be seen as one large Docker engine. Oops. How this looks on a diagram in practice, it's like this. We have one machine called Jupyter Hub Manager. These are the white boxes. And we have another set of servers that are called Jupyter Hub Workers. The Jupyter Hub Manager is running the Jupyter Hub software. And inside there are these components that are responsible for the authentication and spawning the individual notebook servers for the users, and a proxy that you can basically think of as a mapping to tell Jupyter Hub after a server has been spawned for a server, where is this server located exactly. And how this happens is that you visit Jupyter Hub, you don't have your server yet, so it will tell Docker spawner to spawn you a server. It will contact Docker on the same machine. But under the hood, there is a swarm controller container running that will see that you have no container yet. So it will pick one of the workers available in the pool. It will try to pick the least loaded one and command the swarm control node on that particular server to spawn a container for the user. And it will expose a port, and this information will be recorded in the proxy of Jupyter Hub, and you will be immediately redirected to the container that has just been created for you. Now, as a result, it might be that you are on one server, your container is on one server, your colleague's container is on another server, so performance might vary a little bit depending on how other users are using their own notebooks, how heavy computations they are doing, how much memory they are using. So your performance experience may vary a little bit depending on how loaded the actual worker machine is. So a little bit of hardware specs on these machines. The manager is not a very strong machine. It's just 2 cores with 4 gigabytes of memory. But since it's not executing any user code, it's not hosting any notebooks, it is perfectly fine for that purpose. And the workers, we have currently 5 of those. They are 8-core machines with 32 gigabytes of memory. And while Docker allows to put quotas and limitations on resource usage, we tried it and it was not the best solution. So right now you are not limited by the resources. The only limits are the physical limits of the machine you are working on. And all these machines are hosted in the CSCS, Swiss National Supercomputing Center. So a quick evaluation of the service itself. So we have multiple workers, which allows for better scaling and performance and more resilient, because if one of the workers goes down, it only affects a subset of the users. Other users can still work on their notebooks. And most likely when you arrive to Jupyter Hub, you will just get a new container on one of the workers that is still up and running. We can add new workers when we run out of capacity without server interruptions, because the Docker Swarm engine does some dynamic discovery, so it will see when a new worker node has been added. So we don't need any downtime to scale up. We automatically stop containers that have been idle for 12 hours. This means that you haven't touched your notebook for 12 hours, and Docker persists your container so to preserve its state. So it's not deleted, it's stopped, but the memory resources are freed up and made available for newly spawned containers. We also monitor the swarm workers. Yes?
Idle doesn't mean
Uh,
wait. It's part of your problem, part of your program. If your notebook has a very long running.
That means active.
User.
That's active. There is basically a pipeline between the front end and the back end. If then there is nothing happening in this pipeline, which is only possible with user inactivity, then we stop the container. And we monitor these worker nodes, but not the individual containers. So we will see when worker nodes resources are saturated, and then we may come and investigate and see which of the containers is running heavy calculations, and we may ask if this is intended or it's a side effect of something, so then we can intervene. So if you have used the notebook somewhere else, you may notice a few differences from the vanilla flavor. So these changes mostly involve the storage integration and UI changes, because well, most of these changes are done as server extensions, so we don't touch the code of Jupyter notebooks, but it's possible to create like browser plugins for the server itself, and that's what we have done. And we use them to make notebooks load and save to the storage service provided by the Collaboratory, because as I was saying, the containers have a non-persistent storage. So it might be that you were working hard on your notebook, it was saved to disk, and then suddenly overnight the service goes down, it crashes, it's gone. This is not what you want. So that's why we made this extension to load and create notebooks in a safer storage. Mostly because of this, certain UI elements have been hidden, mostly in the file menu, because some of the options that would be available in the vanilla Jupyter Notebook server, like to create a new notebook, has not been done so that integrates well with this storage extension. So the way to create a new notebook is, as you have seen in the Collaboratory, you add an entry to a Jupyter notebook, you create a new file, or you upload a file. But from the file menu, it's been removed. Also, we hide a tree view that Jupyter would provide to see all your open notebooks and all your running notebooks. Also, because it was not easy to, or the integration was not done to work with this storage extension. And one more thing that we do is that we execute a small piece of Python code whenever a notebook is opened in the Collaboratory to instantiate clients that help you interact with the Collaboratory services, so you don't have to do it manually. So the long-term goals for the service is to provide an environment that replaces your desktop. That kind of means, sounds funny, but what it really means is to take advantage of data locality and high-performance computing resources that you probably couldn't match on your desktop. We are not there yet, but that's a long-term goal. We also would like to improve the data management and I/O layer, because if you want to run some analytics on some large data sets, that you might find it difficult and cumbersome to get it into your container where actually the code is running. And this is something we would like to improve. We'd also like to have better Python 3 support, expose the container lifecycle management to users. Because as I was saying, when you have some problem with your container, you have to ask us to reset it. And it would be just better if the users could do it themselves when they feel that it should be reset. We also would like to provide a feature when maybe we would not have a single version of a Docker image that is used by every single notebook, but maybe users could submit their own Docker images that have all the libraries necessary for a specific type of notebooks built in. So, and then somehow you could actually select when you execute a notebook with which image you would like to execute it with, instead of manipulating the libraries yourself from within the notebook itself. As I mentioned earlier, we would also like to add notebook versioning. So if you make changes to your notebook, you can decide to fall back to a previous or earlier version. And also to integrate Jupyter Lab, because it looks really nice and shiny. And that's all I wanted to say. So do you have any questions? Oh, thank you.